Now let's talk about a little bit about the VXLAN. Actually, I would like to showcase this packet because for most of the network engineer, this packet is pain, right? So what exactly is happening, right? So we have these 5 switches, and maybe you can say then this is my access layer switch and this is my distribution layer, and the link between them is trunk link, or all these links are layer 2 link. If that is the case, the communication is very easy, you all know, right? Whatever the message goes from here, ICMP or whatever, right? You are going to put source MAC, destination MAC, L2 header, and then this L2 header, after L2 header, what is going to happen? You are going to put a .1q tag, so that basically if we have multiple VLANs, because we are going to have multiple VLANs, then this switch can understand which VLAN traffic it is for. You all know about it for sure. But now the question is, can we do something like this? And you must be thinking, Mr. Vishnu, like what? Okay. Wait a minute. So here you go. Here you go. So what is going to happen if I change all these links to layer 3 links, suppose? And I hope that you understand the meaning of L2 versus L3. L2 means that packet, basically your source MAC and destination MAC, or the L2 is only read by these switches, and basically your L2 header means the switch is not going to go inside your L2, means they are not going to see L3. But what is the meaning of L3? The meaning of L3 is your L2 will be ripped off, and then the decision is going to be taken on the basis of this L3 IP address. I think you all know that. So now what I'm doing is, see, my same VLAN was there. We have this VLAN 10 here, and we have VLAN 10 here. But now my intermediate, we have another network. It means that the same network can be seen after layer 3 network. It means that I am increasing or extending my VLAN 10 over this layer 3 network, which is very, very interesting thing. Generally, what happens, if I have one computer here, suppose this is 10.10.10.10/24, and then I have one network, which is network number 1, means I have router here, I have router here, and then I have another network, which is network number 2, and then I put this computer here, which is A, and here is V, right? I can't think that I can give 10.10.10.20/24. This should be in totally different network. But what I have done here, I am extending my network, the VLAN, over another network, which was not the case. Previously, we had only switches in between them, but now we are having routers or the layer 3 links. It means that we are extending our layer 2 capabilities over layer 3. And that was the demand of today's data center. Why? Because we have lots and lots of traffic, which is known as east-west traffic. Previously, the traffic was from north to south or south to north. Now there is a lot of traffic between east to west. If that is the case, then basically we need to extend our VLAN. Previously, the extension, we could have extended the VLAN using a spanning tree, but you all know that if we extend the VLAN using a spanning tree, it is a problem. It is a pain for many network engineers, right? And that is why we are using what? We are using VXLAN, right? So what is happening here? And we would like to go step by step to understand this. So what is happening now is I have changed I have computer or server number A, we have server B, right? And now I have configured a loopback on every switch we are calling it these switches as leaf and these as spine. So what is happening on all the leaf? I have configured a loopback interface 3.3.3.3, 4.4.4.4, and here we have 5.5.5.5, right? And now I have changed every link to L3. This is L3, this is L3, this is L3, and I am running any protocol which is known as OSPF. If I run the OSPF protocol, then of course switch 5 knows where 3.3.3.3, is, right? Because it can have now the route learned by OSPF that 3.3.3.3 is reachable via switch 1. As simple as that, right? So this is what I have done. Now my whole sole purpose is that how I am going to extend this VLAN 10 over this layer 3 infrastructure. What is the meaning of extension? The meaning is if I do a ping from A, which suppose I write ping 10.10.10.20, the message should reach here. And how it is going to happen? Just try to understand. When I write the ping, what will happen? First thing first, the ping message of the ICMP will be generating this message, ICMP, right? Source is going to be 10.10.10.10, destination is going to be 10.10.10.20. There is no doubt about it. Source MAC is going to be AA, and suppose destination MAC I know. Suppose, right? Or presume that this I know what is the destination MAC address. Although how to know this, I will be letting you know. Means you can just have a look at my VXLAN series. It is going to be very, very interesting. Now, this packet will be reaching to switch 3, and now the switch 3's whole sole responsibility is to send it to B, host B, right? But how it is going to send? There must be somebody, right? And this somebody is the intelligent guy, or we call it as control plane. Just wait a minute, guys. Yeah, so this is intelligent guy. He knows that the host BBB is actually behind 5.5.5.5. What is 5.5.5.5? This switch, right? But how this guy is getting this information, this is all about control plane of VXLAN. And mostly in most of the data center, we use control plane as EVPN. How this guy gets this information is very, very.
So, enjoying learning? If you have reached till this point of the video, I think you are enjoying learning, and I just do not want to waste your time. I would like to say that if you want to see this complete course, this course is available on my website, which is www.bridgewhy.com. Please have a look at it. And along with this course, there are so many other courses available. If you want to start your networking journey from the beginning, from the scratch, or if you are a seasoned networking engineer, please have a look at this website. So you can see here is my website. The link of this website is also available on the description area just below this video. Thank you so much and enjoy learning.
Interesting and very, very easy. So I am presuming two things here. I am presuming that we know the destination MAC address of this guy, which is BBB. And the second thing I am presuming is that switch 3 understand, it knows from the control plane, from this guy who is the intelligent guy, that where exactly the location of BBB, and it is saying that the location of BBB is behind 5.5.5.5, which is the loopback address of switch 5. Very, very easy, right? In the process, what I have done is I have maintained this guy, right? This guy is VLAN number 10, and this VLAN number 10 is mapped to a number which is 500. Here also I have mentioned that this is my VLAN number 10, and VLAN number 10 is mapped to a number which is 500. By the way, in the next thing, you will be noting that this 500 is nothing but the VNI, virtual network identifier, or we can talk about it later. So the whole sole aim was to send this message, send this packet, complete Ethernet packet from switch 3 to switch 5. What I'm going to do is I will be saying that I am sending it from source IP 3.3.3 towards destination IP 5.5.5.5. Why? Because this guy is telling me that to send this message, you need to go to 5.5.5.5, right? Once this message is reaching to 5.5.5.5, it will be opening it, and then it has to know that where exactly, which VLAN, because there might be more VLANs here, and that is where this number comes into picture. So when I send this message in this VXLAN tab, I will be putting this number 500, which is known as the VNI, right? Once this message reach here, right, it is going to see, okay, the VNI field is 500 and 500 is mapped to 10. It means that I have to forward whatever the message inside me from here to here to this VLAN number 10. As simple as that, guys. Of course, if I want to send this packet out of this interface, I need to put this source and destination MAC, and that is what I have done here. And then you must be thinking, Mr. Vishnu, why this UDP is for? This UDP is just doing nothing but one interesting thing. Because from switch 3, there are two ways to go out. you can see there is one this way or this way, which one to choose. And that is, we decide on the basis of source port of this UDP, which we can change again and again. And if we can change this, then basically we can choose either this one or either this one. As simple as that. So basically UDP is for the load balancing of this. And this packet, whatever the beautiful packet you are seeing here, this is actually known as your VXLAN encapsulation or VXLAN packet. And that is what I would like to showcase you on Wireshark now. If you can see here, this is my VXLAN packet. So what is happening here? I am sending an address resolution protocol message, say ARP. This is my ARP message, right? ARP is the layer 2 message, and that is why it is going to be encapsulated by layer 2, which is right here. So it is going to be encapsulated by ARP. It means that we are going to write source MAC and destination MAC. See, as I mentioned, if you have the foundation strong, you can understand the complex packet also. And then of course, then we need to put it inside the VXLAN, right? Because I am sending this ARP message now. So it is going to be encapsulated by VXLAN, where I need to write V and I. Then what is going to happen? It is going to be encapsulated by UDP. Now UDP, right? Means source port and destination port. Destination port is 4789, which is reserved for VXLAN. Source can be anything, on the basis of which we can decide where to send this message. As simple as that, right? And then it is going to be encapsulated in IP. Here you go, IP encapsulation, where you are going to write source IP and destination IP. And then of course it is going to go over the Ethernet, right? Are you seeing how many encapsulations are happening here? But the thing is so simple. See, I am just sending ARP message. You can send ICMP also. So if I showcase you the same thing over Wireshark, okay, let me open file, open, and then VXLAN. Oops, let me clean it. And maybe this time I would like to show you the ICMP message. See the beautiful message here. ICMP, this is the letter, right? And if I want to send it, of course, we need to use IP. So ICMP and IP, then basically if I want to send it, then over Ethernet, and we want to send this internal message, we will be using VXLAN, then UDP, then IP, and then Ethernet. Very, very interesting, guys.